Question 9, what we're looking at is male pattern baldness. A recent survey was taken with over 1,000 men. Those who exhibited male pattern baldness, which is a recessive trait, coded for by little b allele, 360 out of 1,000 of those were bald. Those that were not bald were homozygous dominant, which were 160 out of 1,000. And then 480 out of the 1,000 men that were surveyed were not bald. However, they were heterozygous for the trait, so they were heterozygous dominant. So when we're looking for the phenotype ratios, we have to understand that you can either be bald, have male pattern baldness, or you are not bald, because this is the phenotype. So in this case, it's going to be 360. You add these two together, because in both cases, the men here are not bald, so you add these two, and what you get is 640. So this is the ratio of bald to not bald. Now for allele frequencies, because we understand that this is a homozygous recessive trait, we understand that this is already Q squared. So in order to find Q, which is representative of little b, we simply have to divide this and then take the square root of that. So in that case, it would be 0.36. 0.36 equals to Q, to Q squared. We take the square root of that. And what we're left with is, so after we square 0.36, what we're left with is that Q equals to 0.6. Now that we have Q, which is little b, we can find big B by simply using the equation P plus Q equals 1. So since Q was 0.6, 1 minus 0.6 equals P. So P equals 0.4. So there we found the allele frequencies for big B, which is 0.4. Now in order to find the expected genotype frequencies, we already found, this is representative of P, we already found P and Q. So all we have to do for this case is square P. So we do that really quick. So in order to find the homozygous dominant for not bald, we would have to get P squared. So all we would have to do is square 0.4, and that will give us 0.16. Now we already found the homozygous recessive for male pattern baldness, and that was 0.36. And then in order to find the heterozygous genotypic frequency, all we'd have to do is 2 times P times Q, which would be 2 times 0.4 times 0.6. Do that, 2 times 0.4 times 0.6, and we would get 0.48. And if you want to check your answers to make sure that these frequencies are correct, you would add all of them and they should equal to 1. So 0.16 plus 0.48 plus 0.36 is equal to 1.